What we've got is we've got questions relating to the motor effect. Now, we've seen from a previous episode, previous lesson, that force acting on a wire in a magnetic field is proportional to the strength of the magnetic field caused by the magnets, the current flowing through the wire, and also the length of the wire in the magnetic field. So force is equal to Bill, if you like. So I think on page 29 of your exercise book, there's a series of questions here. Okay, so I've actually posted these with the answers. However, what I'm going to do is I'm going to take a little bit of time just to go through some of these. Okay, so question number 1. Question number 1 is just talking about giving the symbols in units for magnetic flux density. So magnetic flux density, we've got the symbol B measured in units Tesla, plus the symbol C. We have current I, which is measured in amps, A, and we have length, okay, L, lowercase, and that's measured in meters, M. So that gives us our responses here. So we can now see what we're referring to in the next set of questions. Sorry about the focus. There we go. So I'm not going to do all of these, but we will do some, and we're going to use book FIFA. So let's just put that down. We've got box, underline, when we're doing questions with involving relationships shown as and expressed as formula or equation. We're going to use book FIFA. So we need to box, underline, and grab the data. Then we need to write down our formula, insert, fine tune, and then find our answer. So, question number 1. Calculate the force. So I'm calculating force for each one of these on the following current carrying conductors. So looking at this again, this is our current carrying conductor. This is our magnetic field. We've got magnetic field strength between the two magnets. We'll have a current flowing through the wire, and we're also just working with the actual length of wire that is in the magnetic field. Okay, which in this particular case, the length of the magnet, 0.1 meters. So, right, moving on then to question number, we'll do 2 and we'll do A. So calculate the force, F, we don't know. So we need to underline our data. In this case, 0.2 Tesla, 5 amps and 2 meters. And we need to grab our data. So we've got B, magnetic field strength, 0.2 Tesla. We've got I is equal to 5 amps, and we've got length is equal to 2 meters. Now, we've grabbed our data. Our formula is force equals B I L. We now need to insert, so it's 0.2 times 5 times 2, which will give us an answer of 5 times 10, 2 is 10, a fifth of 10 is 2, and it's force, so it's newtons. So let me check that. 0.2 times 5 times 2 is equal to 2. Yay, got that. Excellent. All right, now I'm going to move on, and I'm just going to do 2, I don't know, 2B, not 2B, 2D. Okay, so 2D, a box force, that's what I'm finding. I need to underline my data, so it's 2D. And then I need to grab my data. So force, I don't know. B is equal to 0.005 Tesla. We have I current is equal to 0.2 amps. And we have length as being equal to 0.015 meters. So looking at this then, I've got force is equal to BIL. Insert my numbers, 0.005 times 0.2 times 0.015. So multiply all these together. 0.005 times 0.2 times 0.015, and that will give me a very small number. It's actually equal to 1.5 times 10 to the minus 5 newtons. Now I can leave it like that, okay, but I'm actually going to call that, I'll use the prefix, and it'll be 15 times 10 to the minus 6 newtons, is actually equal to 15 micronewtons. So that's the motor effect. That's some of the easy questions, 2A and 2D. I'll leave you to figure out the rest. I'll move on to the medium ones. Move on to question number 4. Okay, well, I'm not going to do question 4 because that's just rearranging. I'll leave you to do that. I'm going to move on to question number 5. So I'll do 5 and 6 and 7, and then you can do number 8 yourself. So what we're going to do, all right, up here is bug FIFA. So we need to box what we need to find. So calculate the current. So underline my data and grab my data. So I'm finding current I don't know what that is equal to. I'm told I've got a length of 0.2 meters. I've got a force of 1.2 newtons acting on that length of wire, and it's in a magnetic field which has got a flux density of 0.12 Teslas. So write down my formula. F equals BIM. Insert my data. I've now got 1.2 is equal to 0.12 times 0.2 times I. So I now need to make I the subject. So I'll put a bracket around this, like so. And if I now divide through by 0.12 times 0.2, I'll leave me I on the right hand side. So it's going to be 1.2 divided by 0.2 times 0.2 is equal to I, and that is equal to, in this case, 50 amps. Okay, so I'm going to double check. Always good to double check. 1.2 divided by brackets 0.12 times 0.2 close brackets, and that's equal to 50. So moving on then, number 6. So calculate the length of wire that has a current of 0.5 amps flowing through it. and it has a force of 14 newtons acting on it, and there's a magnetic field of flux density 0.4 Tesla. So box this, I'm finding length, underline my data, grab my data, so I'm finding length. I now need to, current I is equal to 0.5, force F is 14 newtons, and magnetic flux density of 0.04 Tesla. Okay, so F equals BIL. So 14 equal to 0.04 times 0.5 times L. So 14 divided by 0.04 times 0.5 will equal L. So 14 divided by brackets 0.04 times 0.5 close brackets equals 700, which is a rather long piece of wire, 700 meters. So moving on, number 7. So calculate the magnetic flux density. So magnetic flux density is what we're finding. B, the wire of length 1.6 meters has a current of 13 amps flowing through it and a force of 0.8 newtons exerted on it. So the box I've underlined, grab my data. So we have calculate magnetic flux density, so B, what B is, and we have a length of wire L is equal to 1.6 meters, current is 13 amps, and force is 0.8. Force equals Bill. So 0.8 is equal to B times 13 times 1.6, or 0.8 divided by 1, will make B the subject. That's going to divide through by 13 times 1.6. It will cancel on the right hand side, and that will leave me with 13 times 1.6 on the left hand side. The 0.8 divided by 13 times 0.16 will equal B. And that answer is 0.8. Okay, 0.8 divided by brackets 13 times 1.6 close brackets. Now, if you're wondering why I'm using brackets, what happens is if you don't use brackets, it will say 18 divided by the first number, and then it will do that and then calculate and then times it by 1.6 in this particular case. If you put brackets around, what you're doing is telling the calculator to do that first. So the calculator will calculate 13 times 1.6, and then it will take 0.8 and divide it by the product of 13 times 1.6. So our answer in this particular case is 0.038. So 38. So you can see down there 0.03846. Now, looking at this, all my data is to 2 significant figures. That's the most significant figures I've got. So my answer's got to be to 2 significant figures. So looking at this then, I can say it is 0.038. That's Tesla. Okay, now I can make it look a little bit neater. Okay, I can't I'm moving this decimal place 3 places to the right, 1, 2, 3, and that will give me 38 millitesla.